Experiment with the voltage clamp simulator based on the Hodgkin-Huxley model from NeurologyLab, the classic model of neuronal electrophysiology and the one with the greatest biological realism. Membrane voltage clamping is a technique that keeps a cell's voltage constant for a certain time to measure currents and conductances across the membrane during the clamp. Ideal for students, educators, and researchers in medicine, biology, or neuroscience, or anyone interested in exploring neurons and their bioelectric characteristics, which are the foundation of their overall function and neural networks. Visualize in real time how sodium, potassium, and leak currents change, along with neuronal conductance. Modify key parameters such as the probability of opening, closing, and inactivation of voltage-dependent channels, electrochemical equilibrium potentials, maximum channel conductance upon activation, and timescale. Add or remove toxins like saxitoxin and tetramethylammonium, and see how they alter neuronal dynamics with an intuitive design, no complex technical settings, no downloads, and ready to experiment on any device. Harness the full potential of computational neuroscience and become an expert in bioelectricity. Understand the basis of neuronal function, discover its full potential. Conduct your own experiments in a practical, dynamic, and fast way. Understand bioelectricity in a practical and visual manner. Try it today, no charge, by subscribing to NeurologyLab.